So one thing that we do sometimes in math is we need to verify trig identities. So we need to show that those two statements are true. And so what we do is we take, right, you're given an identity, and in order to prove that it's true, what you need to do is start with one of the sides, it doesn't matter which, and then you need to manipulate that algebraically, essentially, until it looks like the other side. You can't work from both sides. You can't like add 5 to both sides, which sometimes people are tempted to do. Instead, you are just working with one side and you try and just manipulate it until it looks like the other. Oftentimes, I will pick the side that looks more complicated because it's easier to take something messy and make it look more simple. A lot of times, as opposed to taking something simple and making it look bigger. So we'll take a look. So here's an example. So this says the cosecant square root of x plus the cosine of x, or times the cosine of x times the sine of x equals the cotangent of x. So I'm just going to put this up here. Recall these things are true. And then I already said this here. It's often easier to pick the more complicated side. So I'm going to start with that side. And then also note here that it's often helpful to rewrite things in terms of just sine and cosine, right? That gets us all kind of, it's like we're working in the same variables kind of idea. So that's really going to be my first step. Instead of writing cosecant square root of x, I'm going to write 1 over sine square root of x. Okay, well, once I do that, I see I have like a sine and that divided by sine squared, and then times my cosine. Well, then 1 over sine of x divided by sine squared of x is really just 1 over sine of x. Well, but then multiplied by cosine. But then that's the same thing as cosine over sine, and then, which is cotangent. So now we've taken that left side and we've made it look like the right side. And so now we've proven it. We've verified that identity is true. All right. Yay. Sorry. All right, so here are some tips for how to verify trig identities. I'm not going to read through all of this, so you can just pause the video and take a look, but these are just some ideas. The thing that I want to say here, and that I know I said in the homework too, is don't be afraid to try something, and it's okay if it's wrong. So, right, so sometimes you'll look at something and be like, I have no idea. And that's fine. Just try something, because once you try something, maybe it won't work, but it'll give you an idea for something else. Sometimes you'll see me just like talking through it and you're like, how does she know how to go from one step to the next and there's no question, she just gets it? Well, 1, I have practice. 2, I've solved these problems before. But 3, it's just trying something, being willing to put yourself out there, and you're not even doing it in front of the class, it's just yourself, and just see how it goes. So that is one of my biggest encouragements with these, is just try something. Okay, it didn't work. Think about what did it get you close to something? What could you have done differently? And then try again. So a lot of it is going to be maybe trial and error, especially to start until you get into the practice of it. And even in the homework video solutions, I know I screwed up on a couple things and I was like, ooh. And so you'll see it at play there as I hesitate. So let's do one more. So here's another one. Again, there's why recall those other identities, just because we're not as familiar with those. Again, my first step is going to be to rewrite in terms of sine and cosine. So secant is 1 over cosine, tangent, sine over cosine, and then sine here. So what I'm going to do first is I'm going to pull that sine up to the numerator, and so I have 1 over cosine minus sine squared over cosine, and then I have common denominators, I'm sorry. And so I can write it like this. Anytime you start to see like cosine squared or sine squared, especially with a 1 in it, you should be like, oh, Pythagorean identity. So over, we know we have cosine squared of x plus sine squared of x equals 1. And so if I subtract sine squared from both sides of x, then 1 minus sine squared of x is equal to just cosine. So I can substitute that in here. Oh, well, that looks like it's going to be easier, right? So cosine squared of x divided by cosine of x is just cosine of x. Yay! And there we go. We are done again because we're awesome. All right. The other thing that we like to do with trig identity or trig expressions is we like to simplify them, because again, when you get into calculus, especially, you're going to get to more problems that are going to be like, oh, and we want to be able to make it easier. And so let's practice simplifying. Again, it's going to look ugly. Let's see what we can do. My first step, again, is going to be to rewrite in terms of sine and cosine. So once I do that, then I see, oh, I have actually just sine divided by sine, right, essentially right there, which is just cosine. So what we've done is we've taken this thing, which looks a little gross, right? And we've made it actually pretty simple. All right, let's try another one. Not quite as simple looking, but once we break it down, it actually gets there. So again, my first step is let's take these, and I'm actually going to pull the fractions apart. Sometimes it's easier to do that because otherwise you get like a denominator with a fraction, which I don't know about you, is not my favorite thing. Always with working, sometimes I'm like, do I divide or multiply? So I always kind of pull them apart, which is what I did there. And then I'm going to remember that, hey, the reciprocal of the cosecant gets me back to sine, and the reciprocal of the secant, which is what this is saying, gets me back to cosine. And so then I just have sine of x times sine of x, which is just sine squared of x, and cosine of x times cosine of x, which is just cosine, or why did I switch the order of those? I have no idea. Cosine squared of x, but Pythagorean identity says that really that's just 1. So this expression up here, which looks like, again, some ugly fraction, really is just equivalent to 1, which is crazy. All right, keep going. So here is another one. And again, don't just listen to me go through all of these. You should take this, pause the video, try and work through it yourself, and then come back and watch me work through the video. Because again, if you're not doing this practice yourself and you're just watching me do it and you're like, oh yeah, I got this, then you'll get to your own and you're like, yeah, I don't got this. So just make sure you're giving yourself the practice in terms of like experiencing the struggle for yourself. With this one, here's kind of what I'm going to do. Right, cotangent is the same thing as 1 over tangent. Oh, those things are reciprocals. Tangent times 1 over tangent is just 1. Well, 1 over cosecant, that's just the reciprocal of cosine. Oh, no, sorry, cosecant. See, I'm crazy, guys. So that just gives me the sine of x. That's one thing that's always bothered me about trig identities, is I always want cosecant to be the reciprocal of cosine because of the c's, and it's just not true. Same thing with secant. Sorry, there's my little tip for you to not screw it up like I do.